Welcome. Today, we're diving into the world of software architecture, starting with a common challenge, the monolithic application. Imagine a single, massive code base where every feature, from user login to payment processing, is tightly bundled together. At first, this setup seems simple and efficient, but as your business grows, so does the code and the headaches. Teams struggle to keep up, changes become risky, and deploying new features feels like navigating a maze. In this scene, we'll explore why monolithic architectures can become a bottleneck for innovation and how recognizing these pain points is the first step toward a better solution. Let's set the stage for our journey from monolithic hell to microservices freedom. As organizations grow, monolithic applications often show clear warning signs. Developers feel overwhelmed by the sheer size of the codebase, making even small changes daunting. The path from writing code to deploying it in production becomes long and error-prone, with manual testing and frequent delays. Scaling the application is tough because different modules have conflicting resource needs. Reliability suffers one bug can bring down the entire system. And perhaps most frustrating, you're stuck with outdated technology choices, unable to experiment or adopt new tools. These symptoms signal it's time to rethink your architecture. Next, we'll see how microservices offer a way out. So, why consider microservices? The answer lies in the need for agility, scalability, and resilience. Microservices architecture breaks down a large application into smaller, independent services. Each service focuses on a specific business capability, making it easier to develop, test, and deploy. Teams can work autonomously, choosing the best tools for their tasks. This modular approach accelerates innovation, reduces risk, and allows organizations to respond quickly to market changes. In the next scene, we'll explore the core principles that define microservices and how they differ from traditional monolithic systems. To understand microservices, let's look at the scale cube, a model for scaling applications. The x-axis involves running multiple identical instances behind a load balancer, improving capacity and availability. The z-axis partitions data, routing requests based on attributes like user ID, so each instance handles a subset of data. But it's the y-axis, or functional decomposition, that's the heart of microservices. Here, you split your application into distinct services, each responsible for a specific function. This approach not only boosts scalability but also simplifies development and maintenance. Next, we'll see how modularity is achieved through microservices. Microservices bring true modularity to software architecture. Unlike monolithic systems, where modules are often just code boundaries, microservices enforce boundaries through APIs. Each service owns its data and logic, making it difficult to bypass or create tangled dependencies. This separation allows teams to develop, test, and deploy independently, preserving modularity over time. The result? Easier maintenance, faster innovation, and the freedom to scale or update parts of your system without disrupting the whole. Let's look at how microservices handle data next. A key principle of microservices is that each service manages its own database. This ensures loose coupling services interact only through APIs, not by sharing data tables. Developers can change a service's schema without affecting others, and runtime isolation means one service won't block another due to database locks. This approach also enables teams to choose the best database technology for each service's needs. However, it introduces challenges in maintaining data consistency and handling cross-service queries, which we'll address in later scenes. It's common to hear that microservices are just another name for service-oriented architecture. So, while both architectures use services, there are key differences. SOA often relies on heavyweight protocols and shared databases, leading to tight coupling. Microservices, on the other hand, favor lightweight communication like REST or messaging, and each service has its own data model. Microservices are typically smaller and more focused, enabling greater agility and independent deployment. Understanding these distinctions helps you choose the right approach for your needs. Microservices offer a range of benefits. They enable continuous delivery and deployment, allowing teams to release features faster and more reliably. Each service is small and easier to maintain, leading to higher code quality. Services can be scaled independently, optimizing resource usage and cost. Teams enjoy autonomy, choosing the best tools and frameworks for their services. Fault isolation improves issues in one service don't bring down the whole system. Finally, microservices make it easier to experiment with new technologies, fostering innovation. Despite their advantages, microservices come with challenges. Finding the right service boundaries is more art than science, and a poor design can lead to a distributed monolith combining the worst of both worlds. Distributed systems are inherently complex, making development, testing, and deployment harder. Coordinating features that span multiple services requires careful planning. Deciding when to adopt microservices is also tricky. For small projects or startups, a monolith might be more practical. Recognizing these challenges is crucial for a successful transition. To navigate the complexities of microservices, architects rely on patterns' proven solutions to recurring problems. Patterns help you make informed decisions, balancing trade-offs and understanding consequences. They cover everything from service decomposition and inter-service communication to data consistency and deployment. By using a pattern language, you gain a toolkit for building robust, scalable systems. In the next scenes, we'll introduce some key patterns and how they guide your microservices journey. One of the first and most important steps in adopting microservices is deciding how to split your application into services. Two common patterns are decomposed by business capability and decomposed by subdomain. The first organizes services around core business functions like order management or billing. The second leverages domain-driven design, aligning services with subdomains in your business model. Both approaches aim to create loosely coupled, cohesive services that reflect real-world business processes. Choosing the right strategy sets the foundation for a successful microservices architecture. Successful microservices adoption isn't just about technology, it's also about people and process. Small autonomous teams are essential, each responsible for one or more services. DevOps practices, like continuous delivery and automated testing, enable rapid, reliable releases. Organizational structure should mirror your architecture, minimizing communication overhead and maximizing team independence. And don't forget the human side. Change can be challenging, so supporting your teams through transitions is key. By aligning architecture, process, and people, you unlock the full potential of microservices.